In the first part, which is the ideal station numbers, we want to give a very brief explanation of how we find and build a model. The map is actually the district of Taipei and the number is the station in each district. And intuitively, we just choose those numbers as our dependent variables. As mentioned before, we consider several factors as our independent variables. First of all, the education level. We want to know whether or not a district with more highly educated people is more welcome to this new public transportation. Therefore, we choose the number of college graduates as our first variable. Then we also wonder if the size of the district will affect the station number. And then we also wonder if more people points to more or less stations. Or is it possible that with more parking place available, the more stations the area might have? Also wonder whether or not different type of industry will turn back different results. In this slide, we choose the number of banks, the number of education institutes, and the number of leisure service providers. So we now have one dependent variable, which is the station numbers, and 7 possible independent variables, which are the number of college graduates, the area of district, the residents, the number of parking lots, the number of banks, the number of education institutes, and the number of leisure providers. So let's now move on to the model building. Without much further information about our dependent variables, we started out with putting them all into the map function and see how it will look like. The result turned out that some of our predictions are actually very insignificant. As you can see from the diagram at the bottom, some of the confidence intervals actually cross both the positive and the negative parts, and they almost centered the size of the area, the number of banks, very hard the number of education institutes, and the number of leisure service provider. So we just simply ruled them out first, leaving us with only 3 other variables. We tried every single combination with and without the interaction term and used the compare function to see how they perform and finally got these 2 models. In model 3, as you can see on the slide, we have education and population as predictors. And in model 4, we have education and population and their interaction term as our predictors. Since the compare result turned out 0.6 and 0.4, we think that both models are actually important in predicting. Therefore, we will use the average prediction model in the following analysis. And these are the reasons of why and how we build our first model of the station numbers.
In the phase 1 is about model introduction. In the MRT traffic model, we try to estimate which variable would affect district traffic the most, and the variables are as below. The first one is station number, second one is area, third one is population, 4 is parking space number, 5 is financial and insurance institution number, 6 is education institution number, 7 is art institution number, 8 is store number, 9 is student number. Phase 2 is about model building. The first step we did is putting every variable in the model, and we will get the result as below. As we can see, found that only station number has a significant effect to the traffic, which means coefficient of BS is totally above 0. As a result, we decide to put station number as a main explanatory factor in the model. Furthermore, we want to know how population and area would affect the traffic, so make both of them as exogenous variable. So now we have 3 variables in the model: station numbers, area, and population. To test which kind of model can explain the number best, we can test different interaction and use compare to rank the model. So now we can build 3 models. The first one is average one, contains all 3 variables in the model and without interaction. Second one is average 2, which contains station numbers, area, and interaction. Third one is average 3, which contains station number, population, and their interactions. As a result, in compare, we can see average 2's WAIC is the smallest, so the weight of this model is the highest. So now we can use ensemble to combine 3 variables in the whole model, and we use the whole model to make the prediction and explanation.
created using Powtoon.